Hi, my name is Makar, and today I'll be talking about digestion and absorption. So, a chemical stage requiring enzymes in which complex food molecules are broken down by hydrolysis, and a state in which they can be absorbed. In most heterotrophic organisms, digestion is extracellular, and the enzymes begin released outside the cell, and the digestion products are absorbed. So, for example, here I drew out starch, and it is attached by the glycosidic link. So when water gets attached to the COC, then the link breaks and it becomes its own separate one. Also here for protein, the proteins are joined by the amide link, and so what happens here also is if the water breaks the link and they become their own separate amino acids. And also here for fat, the same thing happens with water. It just breaks into separate groups. Monosaccharide absorption. Carbs are most commonly consumed as polysaccharides, such as starch, fiber, or cellulose, or disaccharides, lactose, sucrose, galactose. So therefore, they need to be broken down to simpler monosaccharides so the body can utilize it. Monosaccharide units, glucose, galactose, and fructose, are then transported through the wall of the small intestine to portal veins, which can be taken up straight to liver. They're made into various monosaccharides. The first one, including glucose, in low concentrations, it's transported through the mucosal lining into the epidural cells of the intestine by active transport by sodium-dependent transporter. In higher concentrations, it would need a second facilitated transporter. From the epithelial cells, glucose is moved into the capillaries by facilitated diffusion. Galactose is transported in other ways, such as glucose. Galactose is nothing made from nature, so it needs to be absorbed from the breakdown of lactose. Fructose moves entirely via facilitated diffusion. The process utilizes a different transporter to glucose when entering the enterocytes. However, both fructose and glucose utilize the same transporter to exit the enterocyte into the capillaries. The absorption of fructose is much lower than that of glucose and quantitatively limited. Consumption of the large amounts of fructose has been shown to produce a level of fructose malabsorption in almost all cases. Co-ingestion of glucose with fructose has been shown to facilitate fructose absorption. The exact mechanisms for this is still unknown. Amino acid and small peptide absorption are similar to monosaccharides. Glomeruloplasma membrane of absorptive cell need at least 4 sodium-dependent amino acid transports, one each for the acidic and basic amino acids. Peptides don't really have any absorption longer than 4 amino acids. There are a lot more for the tripeptides in the small intestine. Small peptides are absorbed in the small intestinal epithelial cell by the co-transport H+ ions by the transporter peptide-1. Inside the enterocyte, the tripeptides are digested into the amino acids by the cytoplasma. peptides are exported from the cell into the blood, and only a small number enter the blood. So this is what I was trying to show on this figure. Okay, so the transporters bind to amino acids only after binding sodium. The fully loaded transporter then undergoes a conformational change that dumps the sodium and amino acids into the cytoplasm, followed by its reorientation back to the original form. Then the absorption of amino acids is absolutely dependent on the electrochemical gradient of sodium across the epithelium. Then the absorption of amino acids, like that of monosaccharides, contributes to the generating the osmotic gradient that drives water absorption. So last one is the lipid absorption and transport, which I have drawn right here. So in absorption of fatty acids and cholesterol, the lipids that are fat-like molecules can't be dissolved in water, and because they can't be absorbed, they become a big piece of like fat glob. So once they are in the small intestine, it mixes with the bile, which come from the gallbladder. This makes it to emulsify. So once it emulsifies, it becomes small droplets that aids digestion. The major products of lipid digestion is fatty acids and monoglycerides. They enter the enterocyte by simple diffusion across from the plasma membrane. The lipids are transported from the enterocyte into the blood by mechanism. It is then transported into the endocyte reticulum, and it uses it to synthesize with triglyceride. The triglycerides combine with protein inside the Golgi apparatus to form only microns. They are then released from the epithelial cells and are transported via the lactose to the liver. In the liver, they are then modified to lipoproteins and different varieties of lipoproteins. One is such as low-density protein, which will transport lipids in the bloodstream to cells, and then the high-density protein, which will put excess lipids from the bloodstream in tissue and return it into the cell.